Now, for our next talk, please welcome Adelina Simion and Artur Kondas for their talk, Call Me Maybe, Communication Between Microservices. Please.
We all good?
Yeah.
Good. Buon pomeriggio, Firenze. That's all I can say in Italian, so I was prepping that really hard. Thank you very much. So that's the first round of applause, thank you. Second round of applause has to go to the audio guys because the playlist was just slapping, so like, big up. Absolutely amazing. Okay, now jokes are over, or like very beginning, so on you.
Hello, everyone. We're really excited to be here and to spend about 45 minutes with you talking about the communication between microservices. So I'm Adelina Simion, and I'm a tech evangelist at Form 3. I have a background as a Java engineer and as a Go engineer since 2018. And a lot of my opinions are rooted in our experiences of what we've been doing, but also because I've been a back-end engineer, what I'm going to share with you will be from that perspective.
And that's me. I'm Artur Kondas. I'm senior back-end engineer at Form 3. I also do Go. I love Go. It's better than Rust. Of course, we know that. But yeah, I won't be talking much about what I feel like about different languages because we won't get enough time for that. So we can talk about it later, basically.
Yeah, so we wanted to introduce to you a little bit about Form 3 because, as I told you, a lot of what we're going to talk about is representative of how we do things. So we run a fully managed payments API that our clients can integrate with. And we make their lives easier because we take care of all of the security and the scalability concerns of actual payments processing. And we build our platform on cloud-native technologies such as CockroachDB, NATS, and Cilium. And right now we're working to do a multi-cloud project or a cloud-agnostic project, which will bring our platform across the big three clouds. And our team consists of about 250 engineers, and you can see the countries in which they are based. And we're fully remote, so that's kind of how everybody gets together. Okay, so we're not disputing that the monolith is a logical starting point in a startup, because today we'll be talking about the journey that startups usually embark on. So a monolithic application is an application that is built and released as a single unit, and in general they are in one code repository, but they can also be in multiple. And if you're wondering if you're working in a monolithic application, well, the answer to that is what is going to fall over in the case of a bad commit. If the answer is everything, then you're working in a monolith. And it is a convenient way to start up a project because it has less cognitive overload than a microservice architecture. So building microservices is fairly trivial. However, the integration between them and the API design is what is difficult. And this is especially problematic if your requirements are constantly changing as they are in a startup. So what are typical tech stack choices for startups? And tech stacks, already defined tech stacks, liberate us from, as engineers, from making technical choices and then focusing more on building what our business requirements are, or just like actually delivering functionality. So we're going to take you on a little bit of a journey of typical tech stacks. So the LAMP stack was coined in 1998, and it was the first, well, one of the first open source stacks. So it builds on Linux as the operating system, Apache as the web server, MySQL, and PHP. And PHP was had a very active community, and it was a popular choice for building web applications. However, it soon ran into scalability problems, and because it wasn't built for the cloud. And then MySQL and Apache also had issues operating at high volume. So the LAMP stack kind of like fell out of favor. So the next big tech stack was the mean stack, as you can see here. So MongoDB was the document store, which allowed allowed us to save JSON blobs, so you didn't have to normalize your data into a normal form. And it uses, it builds thick clients, and it uses JavaScript in both the front end and the back end, allowing full stack engineers to have less overload because they could use JavaScript on both sides. However, MongoDB ended up having a really bad reputation for durability. And at the time, it does now, at the time it didn't have ACID compliance. And it also became unpredictable under heavy workloads. And as Angular started to move into new versions, there were also many decisions that the Angular community didn't agree with. So then this also fell out of favor. So the latest was the Jamstack, which was coined in 2015, which kind of like looks like we've stopped trying to make a tech stack. So it just gives a simple nod to the APIs, just in a box, as if they don't, yeah, whatever. And it uses JavaScript again to decorate the thick web clients. The markup is the HTML markup that we would have also used in the mean stack. And it is more of a way of thinking than a prescriptive stack, so that actually you're not liberating from making your own technical choices. But we will see that it is a scalable way to build applications, and because the APIs are rich, they also allow us to build really, really cool applications. Okay, so in the API black box, we have all the goodies that we could possibly want. So we have database services, which database as a service became more and more popular because you can just let the vendor worry about the scalability of it. And it also uses third-party services like Stripe or Elasticsearch, any kind of like searching functionality that you might want for your really cool applications. And the API black box will be the focus of what we're looking at today. So let's think about it. As we've matured as systems engineers and system architects, we don't really need a prescribed tech stack, but what we do need from our services is availability, preferably 24/7, scalability as we begin to become more obsessed with all the functionality that we're used to. As engineers, we want data flexibility because we don't want to do like annoying database upgrades or all that kind of stuff. And we want efficiency on both transactional and analytical queries. So if you think about the way we have modern services, is we're used to like recommendations, we're used to having access to a whole bunch of analytics, and all of this is analytical queries. As we will see today, no single stack can handle that, but a well-designed microservice architecture can. So the API box that we saw contains all the goodies that we would want from our Jam applications is held together by 3 patterns that we will look at today. So we will look at the REST APIs, gRPCs, and event buses. So I'm now going to hand over to Artur, who will tell you a little bit more about REST APIs.
And this is my cue when I'm stopped just pressing buttons and I actually start to talk about something. So okay, we start with RESTful APIs, so representational state transfer, because somebody thought this is a good name for something that we use daily. So basically what it is, we have a way of communicating between services in some unified way. In our case, as we're looking at more of a full stack approach, we will be talking about application/JSON, so everything has to be JSON. So we can have a bit of contract between the microservices, how they go about it, how they deserialize, serialize JSONs, and whatnot. But when it comes to communication over HTTP, we have to have, well, headers. We have to use some ways to be able to trace that logic, to be able to trace the request, to work with them in a really nice way. And that puts a bit of an overhead on us as software engineers, architects, you name it, because we have to keep in mind that it has to look a certain way. So then we go into GraphQL, which is, well, like a cherry on top on RESTful APIs, if you think about it. Has anybody used GraphQL here? Nice.
Oh.
Nice, that's good. So as you know, probably you have one endpoint, you fetch the data from it, and it does the magic for you. Personally, it's a good thing. It's a bit of a deadlock if you design it badly, if you design it well, and it works well, but have you ever designed something which was working well at the very beginning and then deteriorated over time? Yeah, exactly. So then we go into gRPC. Ooh, protocol buffers, etc. So it's an open source CNCF approved framework designed by Google, made by Google, and then propagated by Google, hence the G. And you can think about it as using local calls within your code. So you generate the code on one end, on the other end, and then code goes, hey, I want to get something. Okay, you can get something. And just like stick together. And then you basically plug and play. The bad thing about it, or like the mediocre bad thing about it, is basically, again, HTTP, but with extra perks, because you generate the codes, and it kind of maintains itself. The good thing about it is it can be synchronous, asynchronous, it can allow you to stream things. Have you ever tried streaming JSON over HTTP 1.1? If yes, then I salute you, because it's a really tough thing. But yeah, please don't do it. Do you want to say about event buses, or should I? Okay, I can do event buses. So event buses is basically getting the gRPC mindset a bit further. Instead of establishing connection between point A and point B, we go, point A has to call some lake somewhere, point B has to fetch from the lake somewhere. So we take the message, put it in the event bus, something will pick it up, maybe, maybe not. Maybe there's a very good quote from a very good movie I can't quote because it's PG-18. So you send it to the broker, you get it from the broker, and then you have fully asynchronous communication. You can go super low level on this bit because you can go with the event queues on Linux, on like super low level, on the kernel level. You can go super high and go, well, Amazon MQ can do it for you. So like, if it's managed and you're paying for it, that's like absolutely amazing. Yeah. And if you think about it, most third-party services will offer both REST and gRPC integrations. But then the overhead is implementing RESTful API into your code is super simple, and you can do it, well, we can start doing it now, and probably we'll be done with it in the next 15 minutes. Whereas with gRPC, if you haven't, has anybody worked with gRPC here? We can do it in like 25 minutes then. So, yeah, but still, if you haven't worked with it, the cognitive overheads on using gRPC is a bit bigger than using the RESTful APIs. So, it's a demo time. Have you been to a presentation or a conference where the presenter went with a live demo and it worked well? No. So this is not the time again. So we will show you the code, and then we have pre-recorded some outcomes because it never goes well. So our application is a that simple one. We basically will be comparing gRPC and REST, but we'll start with the types. So I had a very long think about what kind of message we can move from point A to point B, and I couldn't think about a good one, so we're moving humans. So we will be basically fetching humans and creating humans, so a bit of playing gods kind of thing. So our human is a very simple human. Well, it has an ID. We live in the future, so everybody has an ID. Then it has a first name, and it has a last name, and it has an age, and then it has the only question you will ever have to ask somebody if you meet them. It's like if they don't like pizza, they're psychopaths or something wrong with them. So,
especially in Italy.
Especially in Italy. Yeah. There's some bad jokes about quattro formaggi, but I don't want to do it. Yeah. Okay. So, as I've said, we have two services. One is REST service, the other one is gRPC service, and we can walk you through them. So, we have two handles written in a way that you can do a lot of really neat stuff with them. So the first handle, as you can see, create a human, basically takes a map of human, which in our case is a database. We thought about implementing database, but then what is the driver you use? How do you fetch it? Where is the database? So we decided a simple map would suffice for the demo purposes. If not, well, generics, and you can do whatever you like. As you can see on line 12, you can do whatever you like. Thank you, Artur, from the back in time. Okay, so we take a human, we decode the human into the JSON. If the human cannot be decoded into JSON, well, we return the error. Then on line 28, this is a super smart way of generating IDs for the humans. I'm really proud of this one. Then we assign the ID for the human, and then we return the human created via JSON kind of a thing. Yeah. As you can see, I'm really bad with jokes. So line 38. So we take, again, a map of humans, and then we want to get a human. So how do we get a human? If we go on the super low level on HTTP, we can do, well, some crazy stuff, and we can do some really nice requests, but that's not the time nor the place for it. So we'll be using query params, which you can see on line 36. So we choose which human to fetch. On line 53, we convert the human ID from a string to an integer, simple stuff. And then in our map database kind of a thingy, we're looking for a human. And if the human has an ID which we wanted to fetch, well, the human is found. And if the human doesn't have the ID we wanted to, we gave it to, then the human doesn't exist. I should have done, I don't know, donuts or something like that. And then the JSON response as a point of reference. What does the method do? The method basically takes whatever you pass into it, marshal it into JSON. Line 73 is a really bad one because we're not checking errors, but that's deliberate. On line 75 to 77, we set the headers, so we don't have to worry about that. And on line 80, rewrite the response into JSON. Okay, how did we test that? Oh, good question, thank you. So we used benchmarking. As you know, probably in Go, has anybody used benchmarks here? Okay, so with benchmarks, you can see how well your code behaves on the heavy loads. You can pass some parameters to it to make it do better, do worse. And this is one of the benchmarks that we will try to show you that gRPC may or may not be better in many things, such as fetching the humans or creating the humans. So as you can see, from the very top, we create the database, which is a map of humans. Then we create the server, and we establish a TCP connection on line 21, and you might be asking, why? And the reason for that is we haven't done any Dockerization on this bit. We haven't deployed that anywhere yet. Any test happens on the machine, because what we wanted to show you is when you're making a startup, you don't have to generate costs from the very beginning. You can actually vet and check if your stack makes sense from the get-go. And on Macs, there is an issue that if you shoot way too many requests, doesn't matter on which port, if it's a TCP connection, then your Mac goes, you can't do that. So we've kind of override this, and we're sending as many requests as we possibly can before the connection dies down. So we're starting the server, we're creating the custom listener on line 31, as you can see here, starting the server, deferring the close to server, creating the transport to remember that we have to close those connections because they will bite us later on. We getting the seed for the generation of humans. And as you can see from line 50, as I've told you before, creating humans, we're living in the future, Blade Runner, or all the cyberpunk kind of thing. Everybody has numbers for names because we've run out of names or something. I don't know, apocalypse. I don't know. So we create a human, and it has a number for a name, and first name, last name. It has an age, because we can age them as we like, and then it answers the questions in the only way possible. We build the payload, we send the payload, and if we're able to build the human, then nothing happens. If we're unable to build the human, then the God tells us we're unable to build a human. So, moving forward, So we've created a human, now we have to get humans. In order to make the benchmarks a bit more repeatable, we've decided we won't be generating the map the way as we generated in create humans, because then we can create a human and shoot the requests in. What we wanted to have pre-established map and then shoot requests to it. So we did really bad thing on line 82, which is using globals, which is bad or good, depending on who you ask. So we created the map of humans with the init method to generate as many humans as we possibly can. We could have used the ones from the beginning of the test, but we didn't, because we want to have the separation of concerns, and testing, and etc. And testing is nice. And then we basically doing the same bit, which as you can see, we've moved one port up, shooting as many requests as we possibly can, and trying to fetch as many humans with random IDs as we possibly can. Because this bit, if you haven't used benchmarking in Go, this b.n will always yield you a random number within the benchmark. It's not preset, unless you preset it. If you do flag b for the benchmark, then it goes haywire. So we're trying to get a human with random ID, and yeah, if the human is there, then we go, yeah, there's human there, and if it doesn't, there it doesn't. One thing that I forgot to mention, this is how we started the server, which is actually a really nice thing. So if you write in Go test for the HTTP services, there's more than 2 ways about it. The 2 most popular ways would be to have a Docker container that will spin up your API with the whole stack in, and then you're shooting requests against that API, because you have, well, really nice separation of concerns. If you don't have money to set up the cloud, or you want to do it everything locally, you can do that, which is HTTP test, which is a standard library, which you can use to generate the server internally within your code. Yeah. So, okay, moving into gRPC. So I know there will be a question, because we will be telling you that with the REST APIs, you can't generate APIs, which is false. And with gRPC, you can generate. And the difference is, within gRPC, the builder is already implemented. Within the RESTful APIs, you have to do the third-party tools to make some generation happen, whereas I can't write proto. Whereas with gRPC, this is all you define, and then the whole magic happens in the background, and gRPC as the protocol, the builder for it, builds you basically the most of the APIs. So again, the same thing, we define 2 methods. On line 11, we define a method that goes, well, get a human with an ID and return a human, and then if you create a human, then you pass the human and you get an ID. Really bad resource name. Next time I need to change it. So again, the same thing. The human has an ID, first name, last name as a string, which will be a number, an age, and the only questions you need to have the answer for. As you can see, we have 2 more files. By the way, all of this code is available on the internet, so if you want to go through it and nitpick, please do. That was written really fast. But yeah, you can move really fast even with gRPC if you need to demo some stuff. So we go into client and the server. The good thing about gRPC is that it's not Go bound. So if we go with the Rust guys and they want to do front end, because we don't want to do front end, we go and we don't like front ends. So they can write front end, establish gRPC connection to our back end, and then go, hey, this is Rust front end and this is Go back end. And they go like, yeah. So it works. So let's go with the client. Actually, we should have gone with the server, it doesn't matter. So Captain House in the building. Okay, get a human. We create the context for the human, so we know that this can time out if it takes too long. And then, well, we get the human and we return the human on this line. As you can see, it's way nicer, way simpler than REST, but if you haven't wrote gRPC ever, then you might go, well, that's not nice at all. It doesn't make any sense. Why do you need a function to map from one point to the other? Well, you don't. Good question. but what we like to do, or what I tried to do, is that you don't have to do JSON Marshall and Marshall when you use gRPC, because it's a protocol-based communication service, so you can pass protocol and protocol, non-marshalling anything. Whereas with REST, well, you kind of have to. Has anybody played GTA Online ever? Do you know how long it takes you to log in when you start? The reason for that is Rockstar, given the time that they had to develop GTA Online, they actually had a really hard time marshalling and unmarshalling that JSON that has to happen from the server into your console or playing device and back and forth. So like, if you look at the logs, on the network logs, what happens, the JSON is massive. And now it's even worse because what, the game is 9 years old, 8 years old? I remember I was playing that in the uni, so like, it has to be really old. So henceforth, we don't do JSON, we just map from one thing to the other. Create a human, same deal. We, well, take a human, map human, create a human, and return the integer of the human ID. And as you can see, the map to human function is also that easy. Well, so you don't have to do anything. And how we tested it, well, the tests are a bit wonky, but they make sense. So also, we've established a server, which is on the local host, basically given that gRPC is a protocol that happens over HTTP/2, it happens over TCP. So the way of thinking how the communication works is basically the same. So we create the client, start the seed, and then we seed as, this is really bad, then we create as many humans with that seed as we possibly can. And the same happens for getting humans, but with another seed. So we just like get humans given the seed. Okay, I can sense that the energy levels went really bad. So let's look at the benchmarks. Yay! Okay, so to the left you have the RESTful API outcomes, and to the right you have gRPC. Again, this was run on the local machine, actually on this one. So on the left-hand side, you can see how many operations per the test duration. Test duration was around 10 seconds. How many humans were we able to get within the operations? The higher the better, because within 10 seconds you want to have as many operations as you possibly can. So as you can see, gRPC is around 4 times faster. If you Dockerize it, it's around 10 times faster. If you use a cloud within the same network and you tweak the network, you can go around 17 to 22 times faster. And where is the screen? Oh, here it is. Okay, cool. So on the right-hand side, you can see how much time it took per operation to get a human. Yeah, okay, works. Didn't. Doesn't matter. I can show you on my laptop. I will actually have to show you about it. Okay, now we will work it out. Well, this one. Okay, so we have get humans. Okay, so get humans takes like this much, give or take. And then this is on the gRPC end of things. This is the time per operation, so it's not that much. And then when you have the RESTful API, it takes around a bit more than this. So again, 4 times as much. No, that's not the end. No, hold up. And then when we create the human, so, okay, operations. So this is the operations thingy. We're software engineers. We have to imagine things as we go, right? So the RESTful APIs takes like this much, again. And then when you create the human, the operations within that test frame takes like, so start from here, and then it takes like up to here, so around 5 times as much. And then if I move to this side, it's basically the same thing, but another way, right? Okay. Yeah, whatever works. This is basically working in a startup, like you have to improvise, and I was really close. It was higher or lower, yeah. So, as you can see, creating humans on time per operation, well, I didn't get into this part, but if I would jump, like, it would be up there. So the RESTful takes a lot of time per operation, and this is mostly due to JSON marshalling. If we lose the JSON bit, then it's a bit faster. Given the protocol difference, HTTP2 is, well, faster than HTTP 1.1. And if we go into Web 3 and HTTP 3, then we can do way more damage. But yeah, oh, sorry, yes, I'm not talking anymore. Okay, I actually am. So pros and cons of using REST and gRPC. As we've learned over the course of the last, like half an hour, the pros is, for the REST, it's easy to use, it's flexible, and it has universal support because, well, you can teach Enhanced to write a RESTful API. And the cons is, well, it doesn't have the native code generation, native being the keyword. You can use Swagger, you can use anything you like. You have to do multiple requests if you want to do if you do multiple operations on one entity, whereas with gRPC, you can do multiple operations on one entity because it's a function. So you can do whatever you like, basically. And it's only as good as designed, but you can use that for basically anything. Whereas with gRPC, it's strongly typed, so it checks your types as you go. Even that we write in Go, you don't know what the consumer of your request will be. So you kind of have to think that they may be able to check to validate the payload. They never do. gRPC has super lightweight messages because it's a byte, it's a buffer underneath. JSON is also a buffer, but it's a way bigger one. And it's super high performance. On the cons bit, it has a low browser support. As of 2 versions of Firefox and Chromium ago, HTTP2 doesn't support streaming messages. So if you had your super application that was streaming data back and forth using server push, now it can't do it. It's not entirely human readable, and it has a really steep learning curve. If you've learned Vim, this is not as comparable because Vim is super easy if you're dead inside. Do you want to say that one? I was talking for a lot.
So we just want to leave with a couple of REST API design best practices. So always use the content type. As Artur previously said, you don't have to use JSON, but obviously everyone would love it if you use JSON. You should use nouns and nest them logically. And then also handle your errors with standard codes, like what you see here with this cat. And also, like, there's http.cat where you can see all the other cats. And definitely use semantic versioning to mitigate breaking changes. You don't ever want to break existing functionality, but with semantic versioning, you can make a new version and then port people slowly over.
And to make it even bigger point, semantic versioning is there for a reason. If you've used Angular across many versions, they kind of use semantic versioning, but with a roll the dice approach, which is, okay, we will change the minor version with breaking the APIs. Like, super fun times.
So decompose your monolith to microservices with good reason. We're not saying that the monolith cannot be scalable. We've seen multiple examples out in the wild of where it is scalable. But if you do decompose your monolith, then make sure you get a good separation of domain separation between your microservices. And finally, we have some microservice best practices. You don't want to make these like mini monoliths that can still take over and that have like mixed concerns inside them, because what then happens is one microservice will take another down. And you should also use good patterns such as circuit breakers to make sure you don't have cascading errors.
Yep.
Okay.
No, okay.
But what about the event buses? What happened to them? Well, I'm here to tell you, I know you've been burning to hear about them. So, as Artur previously said, they allow us to have asynchronous communication between our microservices, and it allows you to scale different parts of your system. And what you see here are some common choices that people use for buses, for event buses. So you've got Kafka and Amazon SQS, which require the consumer to pull the messages. This means that you can consume the messages at a rate that you are comfortable with. And then on the push side, you've got Redis, Amazon SNS, and RabbitMQ, which allow us to build the fan-out pattern. And then you can push these services, push messages to the subscriber. And because they push the messages, then they are the ones that have the least amount of latency, as opposed to the pull messages. And then what you have, we've put here NATs and Cloud Pub Sub, which allow you to build both pull and push patterns. So remember that it depends on at the rate that you want to consume messages at, because you might end up flooding the subscriber with messages if you are using the pull mechanism. So I've made a little bit of a comparison here for you on a select number of them. So with Amazon SQS, you have delivery guarantees of at least once. And then the second flavor of SQS is in order and exactly once. However, Amazon SQS FIFO has a limit of 300 transactions per second. So every time you add extra guarantees, there will be a performance impact. So choose wisely.
In case you didn't know what FIFO stands for, it's first in, first out.
Yes, I should have mentioned. Also, you have max payloads and max messages in queue, and you can compare between Amazon SQS and Cloud Pub Sub. I won't read everything out, but for example, in Cloud Pub Sub, so these two are managed services, and we're comparing between the two of them. And what you have is a retention of 7 days, which you can't extend, and 14 days on Amazon SQS. And also we note that the maximum payload on PubSub is 10 megabyte, but that actually applies to all the messages contained inside the queue. The other three we are comparing as not as managed services, but as the technologies themselves. So RabbitMQ has no maximum payload, and it guarantees at least once delivery. While Kafka has stores messages in topics, which are then further divided into partitions, and it provides delivered order guarantee within a partition, but not throughout the whole topic. And then we have NATS, which has also two flavors. Core NATS is at most once, fire and forget, no persistence. And then you have Jetstream, which provides exactly once guarantees. And the maximum payload is 1 megabyte, but you can configure the rest of the retention and the max messages, as you can see here. So yeah, remember to architect for the delivery guarantees of your system, and it's okay to mix and match, but maybe not too much, because you don't want to insert too many technologies that might have different guarantees and different payloads, because that will then give you more stuff to worry about. So it's all fun and games until it goes into production. So we just wanted to share with you what we use at Form 3. So I previously mentioned about the multi-cloud platform, which is, as you can see on this slide, is hosted on AWS, Azure, and Google Cloud. We use NATS, so that's also one of the reasons that I wanted to share with you, and we use Jetstream because we need persistence. And together with the data centers that we have to have for some regulatory concerns, we can't put everything in the cloud. We need to host something in the data center. Together they form a supercluster, and they pass messages between each other. We use internal REST APIs as well as an external REST endpoint that our clients can integrate with.
And just to make things even funkier, all services that we write are basically cloud agnostic. So,
yeah.
Well, you can plug and play anything. If we will have fourth player, most probably we will be able to plug it in within a week, I reckon, maybe less.
Okay, so this brings us to the end of our amazing presentation, and we'd like to leave you with some conclusions. First, so everyone go home and declare war on your monolith. No, you should safely decompose your monolith, version your APIs, make sure that you have good design practices, and then in order to avoid breaking changes.
So basically also you have to remember to make your system as complex and as expensive as possible, because you're a really young startup, which sadly that's not the case. You have to be very careful about how you build your microservices and make the patterns grow over time rather than changing them again and again and again and again.
Always use the shiniest tech that hasn't been battle tested and just immediately rip everything out and move all of your microservices to use it.
And make your on-call engineers miserable.
No, so as we saw, each communication pattern has its pros and cons, and you should choose for your use case according to the different parts of your system. So it's very normal in for example, the way we use NATs, to use Jetstream and some core, so some fire and forget messages, which is cheaper because we don't need the same delivery guarantees and the same storage of data.
And also, as you saw from the small code demo, you have to make everybody use Vim, which is 100% true, and you can't change my mind about it, so yeah.
We caught you on that one.
Sorry, not sorry.
Yeah, so thank you so much for listening and for bearing with us, and we hope you enjoyed it.
And on to the beautiful notion of, are there any questions?
Yes.
There's one, yes. Hold up, there's a mic coming your way. Or it's not coming. Okay, no, yeah, go with the question, we'll manage.
Thanks for the talk. First of all, you mentioned communication between microservices.
Yes.
You have a types balance with the human balance.
Yes.
Let's say we have service definition of equal of 5,
Okay.
or this type human, and microservices are needed for this type.
Yeah.
So what do you suggest they are?
Okay, so with REST, this is the bit that is funky to figure out. When you have gRPC, you set up a protocol buffer. Actually, okay, so hold up, rewind. The question was, if you have RESTful APIs between the microservices, and they have to use the same type, how do you unify the type? Is that correct?
Exactly.
Cool, okay. So there's no good answer for that, thank you very much. And the realism of it is, if you use gRPC and you set up the protocol buffer from the get-go, well, everybody has to use that protocol buffer. You can't go outside of it, right? Because you have preset type, consumer and the subscriber have to work within the same type. When it comes to RESTful APIs, this is when the thing gets funky if you're not using any generation. So like if you write the code from the get-go, it's up to you as a software engineer to be sure that the type agrees on every end, right? There's no better explanation. Like when you write codes, if you want to extend the API, well, you can start building on top of that API, but then the maintainability of it over time will be just gone. Well, you can't maintain that. So there's some ways you can do that. If you have all the microservices using Go, for example, in our case, well, maybe establish a type package that will propagate the types and establish some validation on the types. If you use more than one language, agree on some validation type. It's a really hard question to answer given the complexity of it and given where you are within your development. If you have 2 languages, that's all funky and fine because you establish the communication contract on the very beginning. If you use more than those 2 languages, 4, 7, 6, doesn't matter. All of them have to suffice the same contract. And it's up to you, the service architect, the product manager, to be mindful of how the API will be used across the stack.
And this is where gRPC really shines, because I've seen you can do all of your proto definitions in a specific package and then generate them for each microservice as you use them. Yeah.
Sorry about that, the mic is now working, so
It's like a stand-up
raise your hand and I'll
comedy
come
kind
to you
of
with
thing.
mine.
Okay,
Oh,
we're taking this side now.
the center.
Yes. We'll get to you. Don't worry, we have time. All right, I think so.
Thank you for the talk. And in a microservices architecture, how can you structure all your services to avoid disruption if a single service has a downtime or something? I mean, you have to program all the services to know that something can be wrong and don't stop working
So we're touching very much on the SRE kind of a thing, because we can start talking about self-healing of the microservices. We can talk about what happens if kind of a thing. And again, this is such a broad question that having an answer right now, which you can just plug and play, is near damn impossible to have. Because how can you, you have to do some resiliency built in within your applications. You have to think about disaster recovery, what happens if. Then we can start talking about, database, maybe having write and read nodes and sharding and et cetera, and then microservices, maybe let's talk about what happens if maybe the application needs to retry the request. There's like the myriad of ways you can tackle that question, and there's no easy answer. That's the worst bit. Also, it's the funkiest bit, because as you saw, the screen went black, and so this is my microservice right now, right? And my microservice went dark. So I had two options in my head. One option was just like,
Be quiet.
if they fix it, then fix it. But if they don't, then we're dead in the water. The other one is to have some resiliency within your microservice, which makes me go grab a chair and build a presentation on the black screen. And then within your microservice, you might think about it, okay, maybe my resiliency within the microservice will be, if I get 401, well, you're not authorized, switch your key. If you get 503, there might be something wrong about it. If you get 400, okay, check maybe I need to change the payload, or I need to retry again, or maybe the microservice wasn't available at that time because the tick wasn't working. So do the request again. At Form 3, we do a pretty extensive disaster recovery bit, which is like we're trying up to a certain point to retry the request, and if it doesn't happen, then PagerDuty, hello, wake up, and you have to go with it. Also, I love PagerDuty, like, it's a good thing. Yeah.
But I definitely think the circuit breaker pattern is the least minimum you can do, just to know, so you know for sure that you're not wasting resources on like 500s from a downstream, upstream, from another service that you're depending on. Yeah.
Hope that helped a bit, I guess. Yes. Other question, yes.
How good is gRPC in terms of breaking changes, in terms of changing changes that happen on the server? I mean, do you need every time to keep in sync the client and the server?
So,
the proto
okay,
definitions?
let me, how do we keep gRPC versioning between client and the server if we change within the
server?
Protocol?
Do you need strong versioning for every change you do?
I have a really bad answer for that, but it's like, you need versioning either way. So honestly, like, if you go into semantic versioning, if you haven't used semantic versioning follows a really simple pattern, which is the major version, minor version, and updates changes. If you go with upgrading the major version, the API might break. So if you change it, then all the consumers of a given service have to upgrade as well. If you go with the minor change, the clause is it should never break the API. So you can upgrade as much as you like, but it shouldn't break the API.
Okay, let me rephrase the question. Can you have non-breaking changes with gRPC?
Of course you can.
Okay.
Yeah.
Great. Thank you.
It's like, yes.
Especially if you're adding fields, right? That'll be like non-breaking.
Yes-ish. Yes. Yeah. I really like how abstract we're going with those questions. Like, at this pace, we will be able to start a startup in the next 15 minutes, which is good. Yes, please go with the question. Sorry.
Going back to the choice between REST and gRPC, what's your opinion on JSON RPC? Because you mentioned like the multiple requests problem. JSON RPC supports batching requests, which doesn't exactly solve the 1+n requests problem, but it can be useful. So what's your opinion on that for microservices?
I'm finishing the talk in 5 minutes, and let's have a chat afterwards, because as much as I love internet, whatever you say on the internet sticks to you forever. So we can have that chat later on. Yes, let's have that chat later on. It's safer this way.
Yeah.
Yeah. Any more questions about abstract topics that we want to answer? Yes, let's go.
Well, first of all, you said that everyone should use Vim, but you actually using NVim, so...
I'm using NVim. It's just simpler to go use Vim rather than NVim.
It must have been a typo in your presentation.
Yeah, exactly.
It happens.
That's the old presentation, yeah.
Never mind. You had a benchmark with the REST APIs and gRPC. Then you presented your choices in publisher subscribers. You didn't mention what kind of serialization you use in your publisher subscriber system. Do you have any, let's not say recommendation, personal wishes for the future in this term? And we don't have a benchmark, let's say gRPC versus RabbitMQ.
Yes, which is a very good catch. So, okay, when it comes to serialization on the pub subsystems, within Form3 we are very, down to the smallest bit. We're keeping track of what has to be within message and how it has to be serialized, deserialized, how it has to be validated before it enters the queue, before it leaves, or when it leaves the queue. So I like to be meticulous about my code, which you may have not seen on this presentation, but then if I would be super meticulous on that, that wouldn't be 2 files per server, it would be a few packages with the validation, and then extending that furthermore, and then it's 10 to 4, and we would be somewhere in the middle of REST package, talking about how to validate the services, how to validate the payload on the JSON, right? About the question on gRPC versus Redis or any sort of pub subsystem, the proper answer, if you're using cloud services, is how deep your pocket is. Of course it is. If you're using it locally, I don't think there's any comparison to gRPC versus PubSub messages. Because, for example, the Amazon MQ allows you to send 300 messages one by one, or it allows you within a second, I reckon, or it allows you to send 3,000 messages per second if you batch them. And this is only the bits that they have in the documentation. But as we know, Jeff Bezos, if you call him and say, hey, I have a lot of money and I need something faster, then Jeff Bezos goes, okay, mister, it's like, here you go. This is like something you can use. And then your spending goes upwards, but you can make it as fast as possibly can. The reason why we omitted that is, well, time, because then we would have to go into how the queue was configured, and then we go into super minuscule detail how to configure them to be even faster. That's the reason why we use pub subsystems within Form3, because they are dead fast. Mm-hmm. And next year we will have something to present, maybe, definitely yes, about that, but I can't say that now.
Last question, quick one.
Don't fight them, they are just asking questions.
No, I'm not joking. Let's go.
Right, so on this beautiful note, thank you for all the abstract and non-abstract questions. I hope you enjoyed the talk and our little stand-up bit, and hope to see you somewhere in the future down the line.
Thank you.
Guys.